Hello friends, good morning. Dr. T. Anuja here. This morning I am going to present before you a new video on a very fundamental subject titled black body radiation, also known as cavity radiation, temperature radiation, or thermal radiation. In the beginning, I would like to tell you one very important observation. By the year 1880, physicists were of the view that classical mechanics was almost sufficient to understand the whole of the phenomenon related to natural observations. But in 1885, an experiment called black body radiation was conducted. The results of this experiment could not be understood by the then available concepts of classical mechanics. It took almost 15 to 20 years to understand this phenomenon, and a new theory was developed known as quantization of electromagnetic radiation. And that can be said as mark for the beginning of new mechanics called quantum mechanics. We will discuss the following points one by one. What is a black body radiation, ideal black body, the wavelengths of black body radiation, the relevance of black body phenomenon, black bodies in nature, graphical display, noteworthy characteristic of some of the curves. We will discuss these points one by one. First point, what is black body? Every material object absorbs some wavelength of the electromagnetic radiation, which is extending from radio waves, microwaves, infrared waves, visible rays, ultraviolet rays, X-rays, gamma rays, and the so-called high energy cosmic rays. Also, every physical object is continuously emitting some rays, mostly infrared waves at normal temperatures. The concept known as black body or perfect absorber body has been of tremendous theoretical and experimental upsurge in the area of modern physics. In fact, the black body concept forced physicists to acknowledge that classical physics was insufficient theory, and it was later supplemented by the quantum mechanics. Black body is an idealized physical object that absorbs all wavelengths of electromagnetic radiation falling on it, irrespective of the frequency of the radiation or the angle of incidence. That is to say, it is 100% absorber because it absorbs all colors of light. It is called a black body. What is black body radiation? When a black body is heated, it emits radiation. The thermal radiations coming out from the black body on heating has characteristic distribution of wavelength, and this depends on temperature. The emission from a black body is called black body radiation. Ideal black body. The ideal black body is a myth because no such a thing exists whatsoever. However, a cavity with a small hole in it and adequately lined with graphite, painted with kerosene black substance is a simple impoverished device called black body, near ideal black body. When light enters into it, it undergoes repeated reflections and can never be reflected out. When it is heated, it gives out radiations. The wavelengths of black body radiation. The radiation emanating from the black body through its whole is not a single wavelength, but a whole range of it. Strangely enough, there is found a characteristic distribution of wavelengths depending on the temperature. At room temperature, most of the radiation is in the infrared region, and as the temperature is raised, energy density, that is the amount of energy radiated per unit volume, the peak is progressively moving towards the lower wavelength side, higher energy side. The relevance of black body phenomenon. The investigation of the relationship between the temperature of the black body and wavelength distribution is very important. And it was the turning point in modern physics. The relationship could not be understood by classical concepts. Thus, it had paved the pathway to the concept of quantization of radiant energy, as also the quantized energy states in atoms. German physicist Max Planck in 1900 introduced the concept of quantization of energy to explain the distribution of wavelengths in the spectrum of the heated radiations emitted from a black body. Black bodies in nature. In nature, there exists no ideal black body. But the Earth, other planets, stars, including the Sun, but not gases or liquid water, are treated as approximate black bodies. Graphical display. Here, an idealized graphical display is given. The y-axis shows energy density, x-axis shows wavelength. Three different temperatures are shown. Two noteworthy points are as the temperature is raised, the peak moves towards shorter wavelength. And secondly, there is a whole range of frequencies coming out of the black body. The following are the noteworthy points of the curves. For each temperature, there is a particular wavelength at which the energy emitted is peaked the highest. Second point, as the temperature of the body is increased, energy density peak shifts towards lower wavelength, that is higher frequency, higher energy side. Third point, the sharpness of the peak is more at higher temperature. Now explanations, that is the development of quantum theory of radiation. Radiant energy is absorbed or emitted discontinuously in the form of tiny bundles of energy known as quanta. Each quantum is associated with a definite amount of energy given by the equation E equal to hf, where the constant h is called Planck constant, f is frequency in units of per second or hertz. It may also be noted that sometimes frequency is written as reciprocal centimeter. This is called wave number. The relationship is f equal to c times f prime, where c is speed of light. A body can absorb or emit radiations in multiples of whole number of quanta of a specific frequency. Based on quantization theory, Max Planck derived the following equation. So I hope you have followed a little bit. Thank you very much.